intersecting lines as well as perpendicular and parallel lines. Okay. So what exactly are collinear points? Collinear points, as it describes here, it is 3 points that lie on the same line. Okay. Any 3 points, okay, such as this, as long as a line, one straight line can pass through it. Okay, these 3 points are what we call collinear. So if I were to label it as A, B, and C, we say that A, B, and C are collinear. Okay, so it must be one straight line. If my points were to be like that, okay, these 3 points, let's call it X, Y, Z, it is not collinear at all, okay, because the line itself is not a single straight line. It is being formed by 2 line segments. Here's go and take a paper. Okay, so I hope that we are clear about what collinear points are. Next, about intersecting lines. Okay. Intersecting lines are when 2 lines intersect at a point. So we're looking at a cross like that. Okay, it need not always be this way. It can be of any kind of orientation. Okay, so as long as they intersect and they meet, there's this one point over here. Let's call it BX. Okay, these 2 lines are what we call intersecting lines. Okay, and this point here, okay, is called the point of intersection. Okay, so for a point, we always mark out with the X. I just so happen label this point with a name called X also. Okay. Next, for perpendicular lines. Okay, it is when 2 lines intersect each other at right angles. So for instance, something like this. Okay, of course you can also have the line being longer. Okay, so in this case, if I were to call this line AB and this line PQ, okay, we say that AB and PQ are perpendicular to each other. Right? Now, this particular point where they meet, where they intersect each other, if I were to call it F, okay, there is a certain phrase that we use to describe it. Okay, this point F is called the foot of the perpendicular. From P to AB. Okay, so it is called the foot because it's at the bottom. Okay, like where our feet are, they are at the bottom. Okay, of the perpendicular. So perpendicular means a line that's 90 degrees from P, the point P, to the line AB. Okay, so if I were to call this A, B, C, D, then A, B, and C, D are parallel. Okay. Okay, next angles, I want us to make sure of how to actually measure angles. I'm not sure how many of you brought your construction set today. If you haven't, I do have some protractors to spare. Okay, may I know how many of you don't have a protractor? You raise your hand. 1, 2, 3, 4, 5. Okay, make sure you return it to me, please. 1, 2, 3. 1, 2, 3. Alright, will you please use your protractor and measure out this angle? And tell me what's the size of this angle. Yes, you don't have one? Okay, you may need to extend the line because the diagram is small. What did you all get? Anybody forgotten how to use a protractor? Okay, I see that most of you are getting 64. Anybody getting different answers? 60? 65? Okay, I think that's fine. 65 is fine, 63 is okay. 64 is fine. Anybody else getting something even more different? 66, 67? Yeah, I hope not, yeah? Okay, so great that we know how to use our protractor. We will need to use it more, okay, in our next chapter probably. Okay? Now we take a look at this. Okay, there are different types of angles and we need to be familiar with their names. Okay? So acute angle, okay, how do you remember the definition of an acute angle? They are angles that are between 0 degrees to, do you know? 89. So 89.999, is it acute? Yes, right? Okay, so it is within this inequality of 0 to 90 degrees. Okay, so between 0 to 90 degrees, even 89.99999 is still acute angle. Okay, try to remember acute, just like the word suggests, is acute, that means it's small. Okay, so 0 to 90. Right? Okay, so to illustrate it, please use a ruler to draw. You can look something like that. Okay, look something like that as well. Okay, these are all how acute angles can look like. Okay, right angle needs us to say it is what size? 90 degrees, right? Okay, so usually we draw it like that and we use a square of some sort to indicate the 90 degrees. Okay. Obtuse angle, yes. Toilet. Okay, let me cover this first. Okay, is it very urgent? Okay. Obtuse angle, I try to relate it to being obese, okay, being fat. Alright, so therefore it is between 90 degrees to 180 degrees. Okay, so how it looks like, it will go beyond 90 degrees. Okay, something like that, but never, okay, arriving at 180 degrees. Okay, and then a straight angle, although very rarely we use such a word, okay, it is 180 degrees because you think about your straight line. angle are angles that are more than 180 degrees but less than 360 degrees. Okay? By the way, x is the unknown of the angle. Okay, so depends on the question. So between 180 to 360 degrees, so more than 180, less than 360, that is what we call a reflex angle. Okay, so a reflex angle would be over here. Okay, otherwise, this is also a reflex angle. Okay. Right. I want us to turn to our textbook, page 79. Okay. Let me just load my e-copy of the textbook. Okay, turn to your textbook, page 79, please. Okay, let's very quickly take a look at practice now 1A. I want you to tell me, okay, the names of all these angles. Okay. So let's talk out some names. For part A, let's do this fast. Okay. Part A, what kind of angle is it? Lucas acute, right? Okay. So Lucas is on that side. Okay. Next, Xavier. Part B is a reflex angle. Okay. And then part C, what is it? Common. Obtuse. We agree with it? Okay, obtuse angle. Great. Next one, part D, Jinshin. Straight angle. And part E, what would it be? Francis.
Not here.
Okay. These are the two names that I always confuse myself with. Also, Asher then. Sorry? Right angle, right? Okay. So, Jinshin here. And Asher. Okay. Part F. What is it? See? What is it? Reflex angle. Quick. Okay. And then for part G, this is the center. Okay, part G, Z. Obtuse, okay. So 176 is the obtuse angle, right? Okay, final two, 336 degrees. What is it, Kyra? Sorry? Reflex. Okay. And one last one. Trina. Oh, how come so many of you not here today? Just now. What happened to all of you? Yushin? Sorry? Acute angle, great. Okay. Okay. So, we recognize our angles now already. Let's go to our complementary and supplementary angles. Okay, so going back to our worksheet. Okay, I want us to be clear that complementary and supplementary angles, they are actually not any form of angle property. Okay, it is just a way to name and describe two angles that have a certain relationship. So complementary angles, okay, as the word suggests, I always think of complementary and relate it to the word corner, and corners are 90 degrees, right? Corners are usually 90 degrees, okay? So they are angles such that they add up to be 90 degrees. Okay, so for example, 40 degrees and 50 degrees. are complementary. Or when it comes to illustration, okay, I can say angle A and B, although they may not be of the equal size. Okay, where supplementary is reverse, okay, not say reverse, but they are the other special number. They are angles that sum up to 180 degrees. Okay. So for example, I can have 20 degrees and 160 degrees. They are supplementary. Okay. We still need to be familiar with these names because sometimes you will see either in questions or in reading in your any book, right? Especially when we go up higher levels, doing more geometry related questions, we may be using words like this. Okay. Right. Now the critical part of this chapter is knowing how to apply properties of angles formed by intersecting lines, as well as for tomorrow when you do your SLS, the ones related to parallel lines. Okay? In primary school, okay, whenever you solve angle-related questions, okay, you can do all the working that you want. You take 180 minus this, minus that, 260 minus this, minus that. Okay? Without any form of reasoning, that's fine, and that's only in primary school. At secondary school level, explanations are required, and therefore, okay, in my notes on this page over here, you notice that there is this one column that says abbreviation. Abbreviation means short form, okay? So there is a short form that we will use for the different properties. So the first property that we will cover is adjacent angles on a straight line. Okay, what is adjacent angles on a straight line? It refers to when we have a diagram that maybe looks like this, okay, and I tell you that this is maybe called A, B, C, and D, okay. If I tell you that this is maybe 47 degrees, okay, and I want to find out what is angle CBD, okay, so angle CBD, if this ABC is a straight line, it will be 180 minus 17 degrees, and we will have 3,743,133 degrees. Okay? So, in primary school, maybe okay, 180 minus 47, giving you 133. Such working is sufficient, but in secondary school, firstly, you must tell me what is the angle that you're finding. Okay? Secondly, you must write down the reason. Okay, what is the property that you use? So this reason that I place over here is what we call the abbreviation, the short form for this property. And it is called adjacent angles on a straight line. Okay, the word straight can be spelled as STR. The word adjacent can be spelled as ADJ. Okay, you must have the word adjacent. Okay, because adjacent means that it is beside. other on a straight line. So for example, I tell you that this is 47 degrees, and I tell you that this is 32 degrees, maybe not maybe 63 degrees. Okay? And then I ask you to go about finding out what is the size of this. Can I just say 180 minus 47 minus 63? No, right? Because they are all completely unrelated to each other. Okay? So, however, they are angles on a straight line. Okay? They are angles on a straight line. But these angles on the straight line, they don't add up to be 180 degrees. Okay? So, angles on a straight line only add up to be 180 degrees if they are beside one another. So that's why the word adjacent is very important when we use it in our property. Okay? Very often students, they are very lazy, okay, I guess. They always drop the word adjacent. Okay? If they don't have the word adjacent, then the property is not correctly applied. Okay? So you must have the word adjacent, right, when you actually write down the reason. Okay? Questions? Brandon, let's use frowning. You okay? Alright, you get it? You don't get it. Why you don't get it? You don't get adjacent part. Adjacent means beside. Okay? So if you solve a question like that and you don't put the word adjacent, right? Okay? This itself is not a correct property. Okay? Because we know that angles on the straight line, these are angles on the straight line, they don't necessarily add up to 180 degrees. Okay? But only adjacent angles on the straight line, they add up to 180 degrees. Okay? Yeah, so that's why must have the word adjacent. You don't write this thing at all. You got penalized mark. Yeah, you will be penalized 1 mark. Okay? And it is from the cover page. There's a geometry segment. Okay? So, not writing reason, you are subjected to penalization. Right? Okay? So must learn the reasons. That's why I'm organizing it neatly for you, okay, in this set of rules. Okay? Next we go on to angles at a point. Okay? For angles at a point, the abbreviation that we use is angles at a PT dot. Okay? So it's a short form. Right? How it looks like, for example, if I have straight lines like this, okay, so maybe this is 130 degrees, this is 40 degrees, this is maybe 30 degrees, this is 130 degrees, okay. So how do I find out the value of, let's say I call this A. Okay. So A will be equals to 360 degrees minus 130 minus 40 minus 30 minus 130. Right? Because they are all angles surrounding one point, which is here. Okay, and we can find that, I hope that my numbers add up. 260. Sorry, I don't give the correct numbers. Wait lah. Okay, actually, tell you what, my numbers don't add up. Let me just change a bit. Sum like that, okay, I do a subtraction in this manner. Okay, this is where I am applying the property angles at a point. Okay. But I can actually do it. Okay. So then there is this other So vertically opposite angles, okay, the short form is VERT dot OPP dot angles. Okay, so vertically opposite angles, if I have straight lines like this, and I tell you that this is 130 degrees, this is 130 degrees, okay, they are actually equal to each other, alright, so, okay, maybe, if this is 130, the one over here will also be 130 degrees, let's call it B, okay, so vertically opposite angles are equal to each other. So I'll write that B is equals to 130. I'll put in brackets, and the reason is vertically opposite angles. Okay. So in our lesson today, what I have introduced to you is the abbreviation, okay, and how we are applying it. These three properties are not unfamiliar to you. We have done it in primary school before. Am I right? Unless you say different primary school. Different eras. Okay, but these are all covered in primary school. Okay, the only thing that we are taking up and leveling up, okay, in secondary school is the way we present and the way we write our answers. Okay, so in the next lesson, when I see you, I think it's next week already. Okay, next week itself, when we come back, I'll show you more problem sums, okay, more questions, okay, for us to learn how to apply and present our answers. Right, so today we just cover the properties. Otherwise, tomorrow, okay, for exercise, we also learn the